Hello there, everyone. I've probably beaten this problem to death over the months and over the last couple years. But I'm just touching on this one again. A lot of people might see this familiar picture on Facebook on different posts. 50 plus 10 times 0 plus 7 plus 2 equals what? And they did a really bad job, whoever did the graphic. And it's not me. It looks more like an X than a multiplication symbol. But I know what they meant. They meant 50 plus 10 times 0 plus 7 plus 2. And the only correct answer is 59. And I did post this question. I put it on Facebook myself, and I even gave a hint and said, you know, the two of the most popular incorrect answers are 9 and 69. All right, and we'll get into that in a bit, but the correct answer is 59. And it was an interesting post, a response from someone, and this is kind of typical of people who keep insisting the answer is 9. We had this response, order of operations is a modern concept. All right, first of all, that's not true. Almost every sentence there's an incorrect statement. So I don't know if this person's like trying to joke about this, make a joke about it, or if it's actually serious, but to say order of operations is a modern concept is not true. It used to be that we worked from left to right. That's not true either. Items in brackets were carried out as one action. Well, yes, if we had brackets, I believe this person might be from the UK based on the Winston Churchill thing. And I will say his first name was Nigel, but I'm not going to go beyond that. Um, Yeah, if you had brackets or parentheses, you certainly would solve those. But we don't. So what do? You go to the next step in the order of operations, which if you are from the UK, Nigel, that would be BIDMAS, which is brackets and then orders, and you have division and multiplication equal precedence, and then finally addition and subtraction. It's a four-step process. In North America, you would use PEMDAS. So yeah, but we don't have brackets, so you move on. There's no exponents. We do have multiplication. We had the 10 times 0. And then he goes on, makes another false statement. Every sentence here. There is a reason the puzzle states don't use a calculator. It's because the calculator isn't woke and does it properly. The correct answer is 9. Now build a bridge and get over it. Well, I've done video after video explaining the differences in how calculators work. Um, you've got immediate execution mode, which follows along like your cheap dollar store calculators, and all that. So that's kind of a tired statement. It proves he forgot his order of operations. He doesn't remember what he was taught or never paid attention, doesn't understand how calculators work. If he would have typed that on his cell phone calculator, he would have seen the answer of 59 because he doesn't understand that his cell phone calculator is already programmed for the order of operations. It understands that because the way it works like a scientific calculator, in that it does not work in immediate execution mode, it works in expression mode. There's different types of input methods for calculators. It has nothing to do with, well, the old calculators do it the old-fashioned way of left to right. That's not true, and it's never been true. Oh my goodness. But you get this kind of stuff all the time. Oh, all right. So every once in a while, I need to go back through this stuff again with people because, well, unfortunately, Nigel's textbook had all that information in there, but he either didn't read it when he was in school or didn't pay attention or forgot. Not sure what the issue was, but the Order of Operations Convention. Let's get back into that again. All right, it allows people to solve for the same answer to mathematics problems regardless of where they are in the world. And the origins of this, and this is as far as Western civilization goes, it can be traced back to the earliest books on algebra in the 16th century. All right, so you're going all the way back to the 1500s. Now, a lot of people think the order of operations is random, completely arbitrary, because they lack a fundamental understanding of what the relationship is between multiplication, division, addition, and subtraction. And I already know some people have already jumped off ship because they read what I said about algebra, that it was in the earliest books of algebra. Guess what, folks? The order of operations applies to algebraic and non-algebraic expressions or equations. All right? It doesn't matter. Just because those are the books that it first showed up in, it relates to both. So that's a typical excuse that some people make because they go, well, this isn't algebra. You just solved the simple math. And first, I'm going to say, there's these acronyms out there that really confuse a lot of people. There's PEMDAS, there's BODMAS, there's BIDMAS. Um, I'm going to say they're not incorrect. What the problem is, people don't understand them. All they do is they look at 6 letters and they think they understand what they mean. But what's wrong is most people don't understand these things correctly because, first of all, it's not a 6-step checklist. All right. If you take example PEMDAS, where you have PEMDAS, the multiplication and division have equal precedence. Division is multiplying by a reciprocal. So you could really write this out. I see how I've written it here. I've written it this way because multiplication and division are equal. It could be MD, it could be DM. When you're looking at an expression or an equation, you go left to right, and whichever one is first, multiplication or division, then you solve that operation. Same with addition and subtraction. I'll actually see people try to tell me that you must do addition before subtraction because the A comes before the S. And that's the only reasoning that they have. That's the only reasoning that they go by because they don't understand that subtraction is nothing more than adding a negative number. That's what subtraction is. It's the same operation, same precedence. Division, again, is simply multiplying by a reciprocal. 10 divided by 5 equals 2, right? I could also write that 10 multiplied by 1/5 equals 2. Division's multiplying by a reciprocal. Then you also have properties, I'm sure Nigel doesn't remember these either, but associative property applies to addition and not subtraction, where you have, 6 plus 2 is 8, 2 plus 6 is 8, 6 minus 2 is 4, but that does not mean that 2 minus 6 is 4. 2 minus 6 is negative 4. It's not the same thing. So there is a difference there between addition and subtraction. But other than that, it doesn't matter the order. Now, people will screw up the order because they don't understand that when I have this 6 minus 2 equals 4, the negative sign is in front of the 2. I can't put the negative sign in front of the 6 just randomly. Of course, that makes it wrong. But I could have minus 2 plus 6. I could have rewritten this as minus 2 plus, negative 2 plus 6 still equals 4. 6 minus 2 is 4. Negative 2 plus 6 is 4. So yes, it doesn't matter the order that you do them, but you got to be aware of your signs. Subtraction is the addition of a negative number, and here it is again. 6 minus 2 is 4. 6 plus negative 2 equals 4. And again, multiplication is nothing more than shorthand for addition. 5 times 4 is the same thing as adding 4 5 times, which equals 20. 4 times 5 is the same as adding 5 4 times, which equals 20. Which way is easier to write? Well, of course, multiplication would be in this case. It's a lot easier to write it. But a lot of people are very confused. They don't understand that multiplication is just repeated addition. You have the associative property of multiplication. It doesn't matter the order that you multiply numbers together. Now, I apologize. That looks more like an X than a multiplication sign. This is not the best graphic. This is supposed to represent a multiplication sign. So, yeah, the people that want to leave that in the comments, go for it. 3 times 2 times 5 is 30. 5 times 2 times 3 is 30. 2 times 3 times 5 is 30. So it doesn't matter the order that you multiply the numbers together. If they're the same numbers, you're going to get the same answer. Kind of like when you're in the grocery store and the cashier's checking out your goods. Guess what? Does it matter the order that they scan things and bag them and put them in your cart? Well, maybe they don't bag them anymore and put them in your cart. A lot of stores you got to do that yourself. But it doesn't matter if they scan the bread before the milk or the milk before the bread or the cheese before the butter. No. If you're ordering all the same quantities and the same things, doesn't matter the order they go through the scanner. And guess what? Your cash register is doing a running total as it's solving. A lot like what you see here, where it might be adding the results, it's adding the products, adding the results of multiplications, keeping a running total. That's kind of how a cash register works. Now, the associative property does not apply to division. 10 divided by 5 equals 2. 5 divided by 10 equals a half, so it's not the same thing. So you have some differences there. It's true that the order of operations is a convention and not a rule. It doesn't make it arbitrary and does not mean you can ignore it. Many just have a poor understanding of what a convention means. It means that people have come together and they've agreed to a set of standards. Order of operations is nearly universally accepted. There's a notable exception in Kenya where students, I think, were taught to solve division before multiplication. So it's a little different. But if you understand how multiplication and division work, you'll soon figure out that they get the same answer from their version of order of operations or from our version. So if you were to flip that and say, well, all multiplication is always before division, then you would get a different answer. But if you understand how multiplication and division work, you'll realize there's no difference in the Kenyan version from what we say multiplication and division are equal and you solve them left to right. And some, just assume that the order of operations can be ignored since it's a convention and not a rule, which again, that's incorrect. It's an agreed upon standard that's been in every mathematics textbook printed in the last century, and even before that. It goes way back. What is it? What is a convention? Well, there's the four steps that I mentioned before, parentheses or brackets if you're looking at BIDMAS, then exponents, or you may also refer to those as orders or indices. Things like square roots and factorials also figure in on step number 2. Anything that's shorthand for repeated multiplication. Step number 3, your multiplication and division are solved left to right. And then addition and subtraction, left to right. All right, some remember it by the acronym PEMDAS, BODMAS, BEDMAS, BIDMAS, doesn't really matter. They all represent the same four steps. Some learn by a mnemonic. For example, there's Please Excuse My Dear Aunt Sally, which is just another way of remembering PEMDAS. It's still the same four steps. I honestly really hate the acronyms. I really hate the mnemonics because what I find is most people just memorize the letters, but they don't understand any of what I've just described. It's far from arbitrary. It's logical. Again, multiplications, repeated addition, divisions multiplying by a reciprocal. Parentheses, one of the things Nigel said, well, we were taught to solve everything in brackets. Well, yes, absolutely. Parentheses or brackets, those are grouping symbols, and the items inside of those have to be solved according to the order of operations, which means that you look inside of the brackets or parentheses and you would solve your exponents, then your multiplication or division, and then your addition and subtraction. So yes, you would if you had them, but you don't toss out the order of operations any more than you toss out the baby with the bathwater. Okay? A number line is arbitrary. The order of operations convention is not arbitrary. I could easily, in a number line, I could easily just display positive numbers to the left of 0 instead of to the right. But we've kind of all agreed that when we make a number line, we like to see the positive numbers to the right, the negative numbers to the left. Could have done that either way. But the order of operations is not arbitrary. Um, you've really, if you think the order of operations is some arbitrary, made up woke thing like Nigel does, well, then you've just ignored the detailed explanation. You probably ignored your education, and you've ignored the detailed explanation I just gave about the relationship between multiplication, division, addition, and subtraction. Um, and then I'd say don't make this mistake. A lot of people will post links to things. There's videos out there about ambiguities, or so on. Yeah, you know what? If you have implicit multiplication where you don't have the multiplication symbol, there are ambiguities and there's issues with how people treat implicit multiplication over explicit, which is a whole different subject. Has nothing to do with this problem. And I've made some videos about the problems with PEMDAS, and how it's understood and misunderstood, pretty much like I've done here. But those issues have nothing to do with the order of operations. All right, but yeah. So again, it's never been left to right with mixed operations. 3 plus 3 times 3 plus 3 is not equal to 21. It's never been equal to 21. All right. 3 times 3 is the same as adding 3 times. It's equal to 15. 3 plus 3 times 3 plus 3 is 15. It's not 21. I'd see a lot of people get this one wrong. Again, multiplication is repeated addition. It doesn't matter what order. Again, look at the checkout example with the cash register. Doesn't matter what order items are checked out. This could be representing, an item here that cost $1 and you bought three of them. Well, 3 times 1 is 3. You might have bought another item that cost $3 and you bought three of them. Well, that's 3 times 3. Then you've got another item that cost $1 and you bought three of them. 3 times 1 is 3 again, and that's 15. Well, if the cashier is scanning your items, it doesn't matter what order those things get scanned, it's always going to equal $15. Could you imagine going to the checkout of a store and checking out and finding out that depending on what order the cashier scanned everything, you're going to pay less or more? That makes no sense, does it? So anyhow, I'm gonna probably end this one here. This video's gone on long enough for sure. But there are the gotchas out there. People put the problems out there, such as this 50 plus 10 times 0 plus 7 plus 2. That problem gets put out there because there's no parentheses. And fortunately, a lot of people forget that when there's no parentheses, you just move on, and you keep using the order of operations. It's a myth where people think there's no parentheses, you just forget everything and solve left to right. That's never been true, guys. But I will end this thing with just pointing out the fact someone did this a while ago, and they made a brilliant point. And they said, well, if you believe that we always solve left to right, please explain the formula for the area of the circle. I mean, ancient civilizations, including Egyptians and Babylonians, had some really accurate approximations for pi that they used in practical applications. And you can see from the formula for the area of a circle that you do not multiply pi by the radius and then square the result. Even the formula for the area of a circle utilizes the order of operations. A equals pi r squared. It's the same thing as r squared times pi. It's always written pi r squared, but you solve r squared before you solve pi, right? You solve r squared before pi. Why is that? Because you solve your exponents before multiplication. R squared, you have exponents. Solve that first, then you multiply by pi. And it's always been written a equals pi r squared. So yeah, the answer again, guys, it's not 9, it's not 69. The people that get 69, not only have they forgotten the order of operations, they've actually forgotten that when you multiply by a 0, you get 0. They've forgotten that. But all right, so again, um, that's all I got. I hope this video has been helpful. to anybody who still believes the answer is nine. I'm trying to gear this video to those people who still believe that their old textbooks told them that you solve left or right. I'm trying to dispel a lot of this mythology that's out there with the order of operations. So hopefully it's been helpful. This video has gone on a bit, but if you found anything helpful here, please consider liking, sharing, subscribing, and I hope to see you in the next video.